Number 36, conversion problems. 100 nautical miles equals blank statute miles. 100 nautical miles equals 115 statute miles. 12 quarts of oil equals blank pounds. 12 quarts of oil equals 22.5 pounds. 45 gallons of fuel equals blank pounds. 45 gallons of fuel equals 270 pounds. 80 degrees Fahrenheit equals blank degrees Celsius. 80 degrees Fahrenheit equals 26.6 degrees Celsius. 20 knots equals blank miles per hour. 20 knots equals 23 miles per hour. 37. Ground speed and true heading problems. If wind direction is 220, wind speed is 030, true course is 146, and true airspeed is 135, what will ground speed and true heading be? Ground speed is 124, and true heading is 158. If wind direction is 240, wind speed is 025, and true course is 283, and true airspeed is 165, what will ground speed and true heading be? Ground speed is 146, and true heading is 277. If the wind direction is 060, the wind speed is 030, your true course is 036, and true airspeed is 140, what will ground speed and true heading be? Ground speed is 112, true heading is 041. And these calculations can be made on the E6B app. Question 38. Flight log example. VFR flight plan. Careful pre-flight planning is extremely important. A wise pilot ensures a successful cross-country flight by getting a good pre-flight briefing, completing a flight log, and filing a flight plan before flight. I guess the question is, how do you do it? A, get a pre-flight briefing consisting of the latest or most current weather, airport, and en route nav-aid information. B, draw course lines and mark checkpoints on the chart. C, enter checkpoints on the log. D, enter nav-aids on the log. E, enter VOR courses on the log. F, enter altitude on the log. G, enter the wind, direction and velocity, and temperature on the log. H, measure the true course on the chart and enter it on the log. I, compute the true airspeed and enter it on the log. J, compute the WCA and GS to enter them on the log. That's wind correction and ground speed. K, determine variation from the chart and enter it on the log. I, determine deviation from compass correction card and enter it on the log. Variation comes from the compass card, and deviation comes from the chart. It'll show in Los Angeles it's -12. M is enter the compass heading on the log. N, measure the distances on the chart and enter them on the log. O, figure the estimated time. What's ETE? It's a departure. An estimated time of arrival and enter them on the log. P, calculate the fuel burn and usage. Enter those on the log. Compute weight and balance. Compute takeoff and landing performance. Complete the flight plan form and file the flight plan with the flight service station. Number Number 39. After takeoff, you attempt to activate your VFR flight plan, but are unable to contact the flight service station. What will happen to your filed flight plan? When a VFR flight plan is filed, it is held by the flight service station until 1 hour after the proposed departure time, and then it is canceled. Question 40. Diversion to alternate or lost procedures. What actions should be taken if you become disoriented or lost on a cross-country flight with no GPS availability? Condition 1, you have plenty of fuel and weather conditions are good. The answer: straighten up and fly right. Fly a specific heading in a direction you believe to be correct, or circle if unsure. Don't wander aimlessly. If you've been flying a steady compass heading and keeping a relatively accurate nav log, it's not likely that you'll have a problem locating your position. If several VORs are within reception distance, use them for a cross bearing to determine position. Even a single VOR can be of enormous help in narrowing down your possible position. Or fly to the station, there's no doubt where you are then. Use the knowledge of your last known position, elapsed time, approximate wind direction, and ground speed to establish how far you may have traveled since your last checkpoint. Use this distance as a radius and draw a semicircle around your last known position on the chart. For example, you estimate your ground speed at 120 knots. If you've been flying 20 minutes since your last checkpoint, then the no-wind radius of your semicircle is 40 miles projected along the direction of your estimated track. If you're still unsure of your position, loosen up the eyeballs and start some first-class pilotage. Look for something big. Don't concern yourself with the minute or trivial at this point. Often there will be linear features such as rivers, mountain ranges, or prominent highways and railroads that are easy to identify. You can use them simply as references for orientation purposes and thus find them of great value in fixing your approximate position. 41. Condition 2 will be you're low on fuel, the weather is deteriorating, you have inadequate experience, darkness is imminent, and or you have equipment malfunctioning. Get it on the ground. Most accidents are the products of mistakes which have multiplied over a period of time, and getting lost is no exception. Don't push your luck. It may well be that in doing so, you have added the final mistake, which will add another figure to the accident statistics. If terrain or other conditions make landing impossible at the moment, don't waste time, for it is of essence. Don't search for the perfect field. Anything usable will do. Remember, most people on the ground know where they are, and you know that you do not. Question 42. If it becomes apparent that you cannot locate your position, what action is recommended at this point? The FAA recommends the use of the 4 C's: climb, communicate, confess, comply. Climb. The higher altitude allows better communication capability as well as better visual range for identification of landmarks. Communicate. Use the system. Use 121.5 MHz if no other frequency produces results. It is guarded by flight service stations, control towers, military towers, approach control facilities, and air route traffic control centers. Confess. Once communications are established, let them know your problem. And comply. Follow instructions. 43. When en route on a cross-country flight, weather has deteriorated and it has become necessary to divert to an alternate airport. Assuming no GPS or DME capability, describe how you will navigate to the alternate. After selecting my alternate, I will approximate the magnetic course to the alternate using a straight edge and a compass rose from a nearby VOR or an airway that closely parallels my direction to the alternate. I can use the straight edge and scale at the bottom of the chart to approximate a distance to the alternate. I can fine-tune this course and decide in distance later as time permits with a plotter. If time permits, I'll start my diversion over a prominent ground feature. However, in an emergency, I will divert promptly toward my alternate. Note, attempting to complete all plotting, measuring, and computations involved before diverting to an alternate destination may only aggravate an actual emergency. Once established on course, I'll note the time and then use the winds aloft nearest to my diversion point to calculate a heading and ground speed. Once I have my ground speed, I'll determine my ETA and fuel consumption to the alternate. I'll give priority to flying the aircraft while dividing attention between navigation and planning. And when determining my altitude to use while diverting, I'll consider cloud heights, winds, terrain, and radio reception. Number 44. What is the most common type of communication radio equipment installed in general aviation aircraft, and how many channels are available? In general aviation, the most common types of radios are VHF. A VHF radio operates on frequencies between 118.0 and 136.975 MHz and is classified as 720 or 760 depending on the number of channels it can accommodate. The 720 and 760 uses 0.025 spacing, so 118.025 or 118.050. With the 720 having a frequency range up to 135.975 and the 760 going up to 136.975. Number 45. What is the universal VHF emergency frequency? 121.5 MHz. This frequency is guarded by military towers, most civilian towers, flight service stations, and radar facilities. Note, all aircraft operating in the United States national airspace are encouraged to maintain a listing watch on VHF and UHF guard frequencies, which is 121.5 or 243.0. Number 46. What frequencies are used for ground control? The majority of ground control frequencies are 121.6 to 121.9. What is a CTAF? CTAF, or Common Traffic Advisory Frequency, is a frequency designated for the purpose of carrying out airport advisory practices while operating to or from an airport without an operating control tower. The CTAF may be a Unicom, Multicom, flight service station, or tower frequency and is identified in appropriate aeronautical publications. Number 48. What is Unicom and what frequencies are designated for its use? Unicom is a non-government communication facility which may provide airport information at certain airports. Airports other than those with a control tower or flight service station on airport will normally use 122.700, 122.725, 122.800, 122.975, 123.000, 123.050, and 123.075 MHz. Airports with a control tower or a flight service station on airport will normally use 122.950 MHz. What does ATIS mean? ATIS. ATIS, ATIS, is Automatic Terminal Information Service. It is the continuous broadcast of recorded non-control information in select high-activity terminal areas. Its purpose is to improve controller effectiveness and to relieve frequency congestion by automating the repetitive transmission of essential but routine information. Number 50. If operating into an airport without an operating control tower, FSS or Unicom, what procedure should be followed? Where there is no tower, flight service station, or Unicom station on the airport, use the multicom frequency 122.9 for self-announced procedures. Multicom is a mobile service not open to public use. It's used to provide communications essential to conduct the activities being performed by or directed from private aircraft.